All right, so here we are again. Now we're not quite done with the sample midterm, as you know. There's a few questions left at the end. Now the sample midterm is actually, the actual midterm, if you haven't noticed, is on Moodle. In fact, let me go show it to you. And so, yeah, here it is. And if you looked at it, you can see that it's pretty much just like the sample midterm. And so it shouldn't take you that long to finish it. So why don't we have them all ready by Monday night at midnight? That should be plenty of time, even if you haven't started it yet. I noticed a few of you have already sent yours in, and that's good. Thank you. And they went to my purchase account. Thank you again, because it's just easier for me to keep them all together in one place. And again, also, just to the extent that's possible, just make sure that they're legible. Just when you look at the pictures, just make sure that it's possible to read them. If they're too small or they're too fudgy, it happens. Just try to do it again. It doesn't matter how many documents you need. It depends on your camera. You might need 2 pictures, you might need 8. It doesn't really matter, as long as they're legible. That's the most important thing. All right, now in the meantime, we're not completely done here. We still left off with number 8. Oh, we only have the last 3 problem sets. Okay, so let's take a look at these. And then we can start something completely new, which is chapter 8. All right, now chapter 8 is completely different from what we've been doing. It's a very important area, which will actually affect your entire life, as it turns out, because it involves interest rates. Okay, well, we'll discuss that when we get there, but it's very, very applied. There's still a lot of math, but it's a very applied area, as opposed to here. These are important skills, but you don't necessarily see these every single day in your life. But with interest rates, yes, those will affect every aspect of your life. And so it's very important to understand how they work. But in the meantime, let's take a look at this one. So what's going on here? An inventor leaves his entire estate to his wife and son. His wife gets 2/3 of the estate, and his son gets the rest. If the son receives if he receives $500,000, what is the total value of the estate? All right, well, we can set this up in a lot of different ways. Let's start out by saying that X is the value received by the wife. Dollars, when I say value, I mean dollars received by the wife. And then Y would, of course, be the value received by the son. Now, what do we know? Well, already right off the bat, we know that the son was given $500,000. So that's easy enough. The tricky part is this. 2/3 of the estate goes to the wife. 1/3 goes to the son. Okay, so 2/3 of the estate goes to the wife. A third goes to the son. So the way we can think about this is that the wife gets twice as much as the son. Okay, the wife receives whatever the son gets, she gets double that. So therefore, we can just say, all right, well, how about setting it up this way? X, the wife's amount, is double the son's amount. You see how clever that was? In other words, whatever the wife gets, it's worth twice as much as the son. And since the son gets $500,000, we can solve it right here without going any further. $1 million. So the son gets $500,000, the wife gets $1 million. Not bad, huh? Okay, so then the question is, what is the value of the estate? Which is simply X plus Y. And of course, that means that we have $1 million plus $500,000. And we're done. Look how easy that was. The challenge was figuring out this piece. Okay, that to me was really the biggest challenge. Now, of course, there's lots of other things you could have done, but I think this is the most straightforward way of going about it. So yeah, and you know, I really think this is the way to go. All right. Now, how about, now we've seen this before, the deck. All right, we have a deck that we want to build. It's presumably it's rectangular. Okay, it doesn't say that, but let's just say it's not a circle. Okay, it's not a trapezoid either. It's 6 by 9. And so therefore, the total area is 54 square foot. The cost is $2,160. Now, they want to know, if that's the case, what would be the cost of a 9 by 12 foot deck? So here's what you have to think about. What is the square footage for this 9 by 12 deck? Okay, the area here if you multiply those together, that's 108 square feet. And therefore, see, that's right there, the secret to the whole thing. Since the 9 by 12 deck has twice as much area as the 6 by 9, it must cost twice as much. Whoops, it must cost twice as much, which means 2 times 2160, which is 4320. And again, there's more than one way of doing this, of course, but I think that would be your best bet, because remember, the whole point of this is that the price depends on the number of square feet in the deck. So if the second one has twice as many square feet as the first, all you have to do is multiply the cost of the first deck by 2, and you'll end up with the area for this, the cost of the second deck. So no matter what the ratio was, in other words, if the second deck had been, let's say, 2.5 times as big, then you would have multiplied 2160 by 2.5. It's that simple. All right. So again, it was like, it's one of those problems where you could get stuck on it, or you can notice it right away. But anyway, so that means we only have one more. Wow, it's hard to believe. Okay, this one involves investments. Okay, so let's make sure we're all caught up. Yes, all right, here we go. One more. A professor invests equal amounts in 2 stocks. All right, so he's done something like this before. So why don't we just very easily and quickly define X as the amount invested in stock X and so Y obviously would be the amount invested in stock Y. Now, what do we know about these? Now, the dividend to stock X is 4%, and for Y, it's 6%. So it says here, oh, by the way, it says here that the professor has equal amounts, which implies that X equals Y. And then in addition to that, if we want to calculate the total dividends to this investment, if the first stock provides a 4% dividend, then 4% of X, and stock Y is 6%, plus 6% of stock Y adds up to $270. So this is how you figure out how much you're earning based on what percentage they're paying you. So in other words, if your dividend is 4%, keep in mind that 4% means the same thing as 0.04. You should never use percentages in these formulas. Always use the decimal equivalents. Otherwise, you're likely to get the wrong answer. We know that 4% means 0.04, and it looks pretty writing it with that symbol, but this is really the way to go when it comes to algebraic formulas. All right, now, once again, we can use the method of substitution because we know that X equals Y. So why don't we use that knowledge to do the following? Replace each X with Y, since X equals Y, and therefore we have, oh, sorry about that, 0.04 Y plus 0.06 Y equals 270, which now you add these together, you get 0.10 Y equals 270. Now, this time you need to multiply both sides by 10 to get rid of that 0.1. And since Y, remember X and Y equal each other, if Y equals 2,700, we know that since X equals Y, X also equals 2,700. And the total investment, now it doesn't ask for the total investment, it just asks for the amount invested in each stock. But if it did, you would just say that the total investment is X plus Y, of course, which means 2,700 plus 2,700, which is, of course, 5,400. All right. So I guess we can congratulate ourselves. This is done. And so now you can take this knowledge and finish up your sample midterm, your actual midterm. Yes, woohoo, that's right. So this block of the course is completely done. Our intensive review of algebra and algebraic concepts is completely done. So now we're going to move into some more applied areas, other branches of math, where...
I have a question.
Yes, go ahead.
Can you go up a little to the
Oh, yeah, sure. Let me
to
know
the
when.
width?
Right there,
Up.
is that?
No, up more.
Up.
To the question before this one?
Oh, okay, sure. This
Yeah.
part. Okay, good. Yes.
Okay. Thank you. I got it.
Welcome. You all set? Let me know when
Yes.
you're done.
I'm good.
Oh, you are? Oh, okay. Anyone else? Now, of course, as usual, I'll be posting this onto Moodle so that you can double check your results. And of course, you've got the tape to watch, the video, I mean. All the videos are stored away in my YouTube account, as you know. And anytime you feel the need to watch them again, you go ahead and do that, and you can watch it as many times as you want. It's kind of interesting because sometimes I notice that people who are not even going to purchase sometimes watch those videos. And so I guess, who knows, there's math fans out there somewhere. But anyway, so now we're ready. We're ready to start something completely new and different. Now, the math in this chapter, some of it's a little involved, but you're definitely going to need your calculators a lot in this next chapter. But what's important in this chapter is that everything we talk about is something that will, at some point in your life, be this will be important knowledge for you. because like I said, it involves interest rates. Now, I guess you've heard of that concept of interest rates, but it's possible you've never directly experienced them. What would be, let's say, the most likely way or one way you might experience interest rates, even now in college? What might be one way in which they would enter into your life? Well, I mean, if you don't know, you don't know, that's fine. But I just wondered if you've actually had any introduction. Loans, exactly. There you go, loans. Student loans. I was going to say, yes, the ultimate example for college students. They probably told you when you borrowed the money how much interest you're going to be charged. And I have no idea what it is these days, but whatever it is, that's going to determine how much you have to pay back. All right, now, the good thing about student loans, though, is that unlike most normal loans, you actually can stretch them out if you really need to. They can be very, very flexible. Unlike, let's say, credit cards, where if you don't pay, you're in loads of trouble. But with student loans, you can always get deferments. There's a lot of flexibility there, but still, at some point, they have to be paid back. And the ultimate cost of these loans will really come down to the interest rate that they're charging you. Another thing you might possibly have encountered is credit cards. If you have a credit card, that means every time you buy something and you don't pay off the full balance at the end of the month, you're going to get charged interest. Oh no, that's absolutely correct. The more you defer it, the more it's going to cost you. But what if, for example, in the early days, you're struggling just to work, you look for a job and you can hardly pay the rent as it is, that the last thing in the world you want to do is make huge student loan payments. So if you can sort of push them off into the future when you have more income. Yeah, you see that, there it is. Yeah, but presumably as you get older, you'll have more income and you'll be able to make larger payments. And so it's good that they give you that flexibility so that you can start low. Well, that's because of the interest. Yes, exactly. If you stretch it out long enough, 5 or 6 years, yes, the interest costs could end up being a full third of the cost of the car. In fact, if any of you live in a house, most likely it was financed with a loan from the bank. And after 30 years, the total amount that you pay for the house could potentially be more than double the original purchase price just because of all the interest. But that's because it takes 30 years to pay it off. So yes, it can really pile up and you really have to be careful. But if you're careful and you plan it carefully, if you make sure that, you only do this when it's necessary, it could give you a lot more flexibility so that when you do have more money, you can pay more, and when you have less money, you can pay less, because you don't want to find yourself being forced to choose between paying your rent and your student loan. I mean, you don't want to be in that position. But if you can say, listen, can we, defer this for a while until my salary increases, they're perfectly happy to do that. But yes, of course, you'll end up paying more for it that way. Yeah. So no, it's, ooh, yeah. I mean, living is very expensive. I mean, especially in this area. There's a lot of other parts of the country where, especially real estate in this area, is horrifically expensive compared to most of the rest of the country. In fact, there's a lot of TV shows on that you may have seen. There's one in particular called House Hunters. I don't know if you've ever seen it. And what'll happen is that, they'll follow around, let's say, a couple who needs a new house or a new apartment, and they'll show them what's available. And in some of these cities, the rents are absurdly low compared to what we're used to in this area. And you get these people who are complaining about having to pay $2,000 a month for 3 bedrooms. And you're like, well, what planet have you been living on? But it's the cost of living can be very, very different in different parts of the country. So if you're, let's say, lucky enough to do a job that can be done anywhere because it's online, for example, then you could save a lot of money by living not in this immediate vicinity and living someplace more cheaply and yet still having a nice salary. So that would work out very nicely. On the other hand, there's some jobs where you really have to be in this area. And so you just have to pay, the cost is very, very high and there's just no getting around it. But anyway, so what we're going to do here is look at interest rates in general. How are they calculated? Okay. How do you know how much interest you're actually paying? That's what we want to address in this chapter. So along the way, we'll talk about different types of interest rates you might encounter in practice. And also this cuts both ways too. If you actually have money to invest, you want to know how much you're actually earning from your investments. So, when you get to that point in your life where you have money to save, this will also come in very handy too, because you'll want to know how much you're actually earning from your investments. Yes, that will happen one day. Yes, you will have money, and yes, it's hard to believe now, and you'll have to think carefully about how to invest it. So anyway, the title of this chapter is Consumer Math, but like I said, it's primarily focused on interest rates, so that you'll understand. For example, if you go to a bank and borrow money, let's say to buy a car, you have to understand how much they're going to charge you every month. In other words, where did they come up with those monthly payments? And by the way, that's ultimately what's going to determine whether or not you can afford that car, because you'll have a monthly budget and you'll know roughly how much you're making every month, and you'll be able to figure out how much you can really afford. And so it's really the monthly payments rather than the sticker price of the car that ultimately determine whether you can afford that car or not, because the monthly payments take into account interest, whereas the sticker price does not. Or if you're buying a house, which will come down the road, maybe, not necessarily, but you might buy a house. There's all kinds of reasons why you might be introduced to or need to understand interest rates. Credit cards, another perfect example. If you have credit cards, they charge a very, very high rate of interest, much higher than for some of these other loans. In fact, why don't we stop and think for a second, just as a thought experiment, why is the interest rate on a credit card so much higher than the interest rate on a car loan? What would be the logical reason for this? Ooh, that's a good question. Wonder what's going on here. Now, of course, it's possible that you've never had a credit card and you didn't know this. And of course, it's unlikely that you have a car loan already. I mean, it's possible. I don't know. Does anyone here actually have a car loan? No, okay. That might have to wait till after you graduate. But you do only have to be 18 to borrow money like this, because at 18, you are legally able to sign contracts. And that's why you have to wait till 18 to borrow money like this. All right, well, think about this. What is the biggest problem that a lender faces? Imagine yourself being a bank and you're thinking about lending money to customers. What is the one thing you have to worry about the most? Like if you see a customer walking in the door says, I want a credit card, please. You might say to them, sure, here it is. But what would you have to think about before you decide to give that person a credit card? It's an important word. It's 4 letters. Oh, here we go. What will they use it for? Yes. And even more importantly, okay, I'm going to type this amazingly important word. Risk. What does that mean? What risk are we talking about here? Well, here we go. Yes. Is it not working? Or specifically, what if they don't pay you back? How do we know that the customer will pay the money back that they borrowed? Well, the answer is we don't. Okay. Let's say you get a credit card and you realize you can't make the payments. What happens now? Well, the bank doesn't get the money back that they've lent you, do they? And so they have to worry about that. In fact, especially with credit cards, they have to say to themselves, listen, what's the likelihood that this person will not only pay back the money that they owe us, but all the interest that we're charging them? Now, with a car, we have the same problem, but what's different about a car loan? If you don't make your car payments, what can the bank do? That they can't do with a credit card.
They can repossess the car.
Exactly. That's right. If the owner of the car doesn't make the payments, okay, if the car owner does not make the payments on time, the bank can repossess the car and sell it. So as you can imagine, this greatly reduces the risk of a car loan to the bank. Can we do that with a credit card? What if somebody spends all their money on a very expensive vacation and when they come back, they say, whoops, I can't make my payments? If the credit card owner or the borrower who has a credit card can't make his or her payments, there is nothing for the bank to repossess.
The price goes up every month.
Oh, sure, the balance. Oh, absolutely. Oh, no, the amount that you legally owe them keeps going up and up and up. But the thing is, at some point, though, the bank may have to say, listen, this customer is never going to make these payments. And so what they may have to do, what they often will do is they may try to sue the customer, but if they don't think there's any realistic chance of getting the money, they may just write it off on their taxes. You know, they do have the ability to write off bad debts, but it's a very costly process. They don't want to do that if they can avoid it. So what they might do instead is negotiate with the customer for better payment terms, but it's still very costly and expensive to the bank. So the bottom line is that the credit cards are much riskier to the bank than car loans. And so this is why interest rates on credit cards are higher. The bank hopes to earn more money from the credit cards so that it can absorb any losses that occur. All right, in other words, by charging you more money, they have more profits. And then if people don't pay, then at least that can offset some of their losses. So they're trying to make sure that if something goes wrong, they at least have enough money to compensate them for it. So they always charge more money for riskier loans. Now, having said all that, what about buying a house? From the bank's perspective, is a mortgage, which is a loan to buy a house, by the way, safer than a car loan? What do you think about that one? And remember, the word mortgage specifically refers to a loan that was taken out to buy property, including a house. What's different about a house than a car? In both cases, the bank can repossess the asset if payments are not made. But what happens to the value of a house over time? Typically, not always. Well, the value of a house typically increases over time, while the value of a car does the opposite. Therefore, lending money to buy a house is safer for the bank than lending money to buy a car. Because let's say if the bank repossesses your car, but it's not worth very much anymore, they could still lose money. But if they repossess a house, they may actually make a profit. So there's less risk involved. Therefore, the rates the interest rate charged for a mortgage is typically lower than for a car loan, because it's even safer. The bank says, listen, no matter what happens, something goes wrong with this mortgage, we can take the house back and sell it, and we'll almost certainly get more money back than the person paid for it. So there's even less risk involved, and they're really happy to make a mortgage. Not only that, but it locks in payments for 30 years, and that's not too bad. So many banks, many, especially smaller savings banks, this is where almost all their profits come from making mortgages for houses. Anyway, so now I do want to mention too that just as an aside, you may accidentally run across this in the news sometimes. I'm going to ask. Oh, I forgot. I haven't done a poll in a long time. I'm going to throw a poll up there just out of curiosity to see if you have. Whoops, what's going on here? There we go. If you ever listen to or pay attention to the economic news, here we go. Are interest rates at unusually high or low levels right now? And this is by historical standards compared to what we're used to. What's going on here? I know why. It's way down here. Okay. All right. This is just out of curiosity. This will let me know if you're paying attention to the financial or economic news. Not that anyone expects you to, but you may have an interest in this stuff. And all right, well, we're going to find out right now. I see a lot of you are afraid to vote. No, maybe not. Well, if you don't know, you don't know. I mean, because, let's face it. I mean, it's not. I'm seeing results. Oh, that's very weird. It's not showing up on your screen. Wow. I don't know why it would not show up on your screen and everybody else's. Is it hidden? I mean, it's possible that it's just hiding somewhere that you can't see it. Is that a possibility?
I don't know.
All right. Well, I'll tell you. What's your vote then?
I am not sure.
All right, that's all right. I should have had a third one for I'm not sure. Anyway, so I'm going to tell you right now, and you can see, everyone can see the results right here. 75% said high, 25% said low. Well, the answer is actually low. All right, so that just means that not yet. One of these days you'll start paying attention to financial news, and that's fine. That'll probably happen when you have enough money to save and invest, and you'll say, maybe I should start paying attention to what's going on in the stock market. Stocks are really booming right now, though, on the other hand. So in a way, this is actually a good time to be investing because you've got a strong stock market and you've got very low interest rates, which means you can borrow money very cheaply. It doesn't always work this way. This is very unusual by historical standards. So, but you know what? It's eventually you'll slowly start finding yourself maybe taking a quick peek at the Wall Street Journal here and there. And but let's just say that one day you wake up and say, you know what, I think it's time that I start paying attention to the markets. I'll tell you what, here's a really good website that you might want to investigate. And I'm just saying, just in case, I'm not suggesting you must do this or must do that. This is CNBC, and they have all kinds of wonderful financial news all gathered together in one convenient location. Well, yeah, sooner is always better. That's my opinion. The sooner you start getting yourself ready, because the longer you are able to invest your money, the more you'll have when you retire. So I would strongly recommend that if you're really interested, that you start learning as quickly as possible, as much as you can about the markets, so that you can do a good job investing your own money when you actually have some. So this is a place where you can find the daily news about the financial markets. Across here, they have information about the major, these are the 3 stock indexes that everyone pays attention to: the Dow Jones, the Standard & Poor's 500, and the NASDAQ. Green is good. That means it's going up. You have money, oh my God, well then you should start investing. At the very least, you can start looking into stock funds, or just something very safe and conservative, just to get the ball rolling. You can sign up for a brokerage account, and somebody who can give you some advice, and just get started. Just dip your toe in the water and start to learn how this works, because if you leave all your money in the bank, you're never going to be able to retire. GME, what is GME? What does that stand for? GameStop. Oh my God. I don't know. Safe and conservative. I wouldn't call it that after the run it's been through. When I say safe, I mean, like really big, let's say, for example, Apple might be a nice choice, or, some of these really big time companies, Amazon, that it would be impossible to imagine them losing money. But just to get the ball rolling. What you really do need to do is read the news and see what's going on. How else will you know what to buy if you don't know what's going on in the markets? So all this wonderful news is here. And there's also all this information about US markets and, even cryptos. Some people are interested in cryptocurrencies. I don't have the faintest understanding of them, but here they are if you're interested. We have business, economy, finance, and all these great articles about what's going on, like with job growth and inflation and trade deficits and investing, and all this good stuff is here. But anyway, maybe this can wait for the future, but at some point down the road you'll want to start thinking about your own investments. And the best way to invest is to have a good understanding of what's happening in the markets. All right, enough said. Let's get back to this. Now we're focusing our attention on interest rates. Now, interest rates in the economy are low, as I've said. There is one organization that is ultimately responsible for interest rates in the United States. So I'm going to do another poll here just to see if you've heard of this organization. Watch this. Who's in charge? Okay, who sets interest rates in the US? Okay, here we go. The House of Representatives, the Senate, the President, the Federal Reserve System. Okay, here we go. Oops, it's not what I wanted to do. All right. Well, you know what? We're almost, I guess that's pretty much everyone who's going to vote. Well, it turns out I'm very impressed. Most of you got it right. The Federal Reserve System is actually the one that sets interest rates in the United States. Now, this is really more a topic for an economics class, but I think what we'll do is at the end of this chapter, I will find some videos which give us a very quick overview of how the Federal Reserve System works, because I think it's important that you understand what the Fed does and why it changes interest rates the way they do. In other words, what are they trying to accomplish? It's extremely interesting in its own right, but it's something that everybody, I mean, every single adult person should have knowledge of this, because at some point, all of this will ultimately affect your life, because like I said, interest rates ultimately can affect everything, from the amount of money that you earn in your bank account, from the amount you pay for your car loan and your student loan, how much do you pay for that house. So this is really important. So I'll make a note to myself, when we're done with this chapter, we'll watch a couple of videos about how the Fed works and what it does. And I think you'll find it extremely interesting. And if you've had an economics course, you already have some background in this area. And I think you'll agree that this is quite an exciting topic. So we'll save that for later, though. Anyway, let's take a look at our notes for today. We're going to start by considering what we call simple interest. So there's different kinds of interest that you can pay on a loan or earn from an investment. Simple interest is all about interest paid on the amount that's been borrowed or lent, which is called principal. Okay, we're going to use that word quite a bit in this chapter, principal. Principal spelled P-A-L, by the way. This is the amount of money that's either been borrowed or lent. And the interest that's charged directly on the principal is known as simple interest. You'll see why when we get to the more complex version of this. And the amount that you pay depends on the principal, but also the time over which you've borrowed the money and the rate of interest that you're being charged. Okay, so, all right, so hold on. I have to go get something in the other room. I'll be back in 1 second. All right, here we go. So we're going to introduce some important variables. We'll use these throughout the chapter. So we want to get used to these right away. So we'll use the letter capital P to represent principal. Again, this is the amount that we either borrowed or lent. Lowercase r will represent an interest rate, which is the percentage of the principal that's being either earned by the lenders or paid by the borrowers. Okay, obviously R for rate. All right, so far so good. All right, so now we also want to introduce variables for time. And we'll of course let that be T. So T will be time, but sometimes that is referred to as the term. The term of a loan, for example, is the time frame over which you have borrowed the money. Now, A is something new. Now, I don't know why the book chooses to call it A. It stands for something called future value. That's what we're stuck with. But what this means is if you put money in the bank today, A, or the future value, represents how much it will be worth at some point in the future. Okay, so if you start, let's say with $1,000 today, Actually, let me just throw this quick example in here. Imagine that you start with $1,000 today. And in 5 years, that balance in your account is, let's say, $1,120. This is the future value of $1,000. It's a pretty straightforward concept. It just means if you have money today and you invest it in something, how much will it be worth in the future? And that's what we mean by future value. This is often a question that we ask ourselves when we're investing. How much will we have? And then finally, now you notice how we have interest once again. This is different though. Little r is the rate of interest. That's a percentage. This interest is the dollar amount. Okay, so we have to be careful to make a distinction here. This is the interest rate. The magic word there being rate, and it is a percentage. Whereas I is the dollar value of our interest. So we have to be careful to understand the distinction between the two. All right, now once we have those in place, we can define some formulas. Now we're going to start out with some very basic formulas. They will not stay basic for very long, but we can get a lot of mileage out of our first formula, which is going to tell us how much simple interest we will pay if we borrow money or how much we will earn if we lend money. All right, here we go. So we'll start with our first formula. And when you see it, you'll say, oh, how easy does it get? Okay. Well, there it is. Now look how simple that is. You've got the dollar amount of interest that you've earned. Now this is simple interest, remember. Principal, which is the amount that's been borrowed. This is also in dollars. This is the rate, which is a percentage. And this is time, which is typically measured in years or fractions of a year. All right. So let's look at some simple examples. An investor deposits $1,000 for 1 year in a bank account that pays an interest rate of 3% per year. So we can calculate this very easily because you can see the principal is $1,000. The rate of interest is, now, by the way, I think I already mentioned this. When you see 3% like that, you should immediately convert it into a decimal. Otherwise, you're going to get the wrong answer. And then, of course, it's a 1 year. Now, since t is measured in years, then t equals 1. And so what this says to us is that during the year, this investor will earn $30 worth of simple interest on that deposit. Now, of course, in this point in time, you're not likely to get that much interest on a savings account like that. In fact, if you may have noticed, if you ever go into, even if you don't go into a physical bank, some supermarkets actually have their own bank in the store. And, if you look very carefully, they'll have signs all over the place, which will explain to you what kind of interest they're paying on their accounts. And in fact, what we can do, just for the fun of it, let's take a quick look at the internet and see what kind of interest rates we're receiving these days. Let's see what we can come up with. The national average interest rate for savings account is 0.07% for the week of February 24th. 0.07. 0.07%. Let me just point this out to you. 0.07% is the decimal equivalent of 0.0007. So that, remember I said before that interest rates are at unusually low levels right now. Well, this is an example of that. 0.0007. If you put your money in this bank account for a year, how much interest would you earn? Let's find out. And when you look at this, you'll say, wait a minute. Set 1,000 times 0.0007. That's 70 cents worth of interest. $0.70, not $30, 70 cents. So this is one reason why people are turning to the stock market, because if you keep your money in this bank account, you'll never retire. You can't possibly live long enough. I mean, that's point, but that's because rates are unusually low right now. In the past, bank accounts would typically pay 5.5%, but that was during different periods in history. So right now, rates are at preposterously low levels. But think about it this way. You may say, well, that's a problem because I won't earn very much money on my investments, but it also means that borrowing money is very, very cheap. In other words, if you were in a position to buy a house, now is the perfect time to buy it because rates are never likely to be this low again, at least not during our lifetimes. But anyway, assuming 3%, at the end of the year, we will have earned $1,030, which means, by the way, that the total amount of money in the bank account is actually $1,030. Okay, so the total balance, because you still have your $1,000, is 1,000 plus 30 is $1,030. Okay. Now that brings up this topic, future value. So in other words, in our example we just saw, the principal that we had in our account initially was 1,000. We added $30 to that. So this 1,030, which is our total balance at the end of the year, is also known as the future value of $1,000. And we're going to call that A. Okay, so I'm sure they must have had their reasons, but the authors of the textbook have chosen to call this A instead of F. So I don't know, we're stuck with it. Just remember, A means future value. Now, algebraically, as you can see directly below, because I equals PRT, that means this becomes A equals P plus PRT, or when we factor out that P, So that means there's two equivalent ways of calculating your future value. This one and this one. Either one, of course, will give you the right answer. Okay, but this is only if you need to know the future value. If you just need to know the interest, then you can stick with this formula, I equals PRT. Okay, but for future value, you need to do one of these two things. Okay, now, what if we have a situation where we're lending or borrowing money for less than a year? All right, well, what we have to do is think about it this way. If T represents years, then let's say 6 months. We would think about that in our formula as half a year. So, and then 3 months, for example, could be thought of as a quarter of a year. So all we're saying here is that if you do have a situation like that, the T in your formula will have to be replaced with a fraction. In other words, for 6 months, don't put a 6 here. Use 0.5 for 1/2 of a year. All right, like here's a good example of this. Suppose an investor deposits $1,000 for 6 months in a bank account that pays an interest rate of 4% per year. So then T in our formula will be not 6, but 1/2, which means half a year. So going back to our new formula, the $1,000 is the principal. Now the interest rate, just leave it at 4% because it'll be adjusted right here for the fact that it's only 6 months. So we'll end up in 6 months with $20 worth of interest. If we'd left the money there the whole year, then it would have been 40. But since it was only 6 months, we got 20. Now, it turns out that we can take this formula, this basic formula, I equals PRT, and we can actually rearrange it algebraically to solve for other terms that we might need. For example, what if we're trying to solve for the principal in our account? So you can see how easily we can take this and what I'm going to do is divide both sides by RT. And you'll see that these drop out. What do you know? And that's, of course, this only rearranged slightly. The principal could be thought of as the interest dollar amount divided by RT. So if we have the other variables, I, R, and T, and we need to know P, we can easily use the same formula rearranged algebraically to solve for P. Just kind of convenient. Okay, so why don't we look at a quick example of this? A homeowner has borrowed from a bank to finance various repairs. The simple interest is $20,000. The interest rate is 4%, and the principal will be repaid in 5 years. How much money did the homeowner borrow? All right, now the formula is P equals I over RT. So this will be our challenge of the morning. Why don't you plug the numbers in and see what you can come up with? And remember, the rate should be written not as 4%, but 0.04. All right, why don't you take a minute and see what you can come up with? All right, let me know if you have a number. Here we go, somebody's got it. It is in fact $100,000. All right, so let's see why. Oh, we got another one. Perfect, yes. Right, so another, again, don't forget, make that interest rate a decimal. 20,000. Now, when you do this on your calculator, by the way, you've got to be really careful. Let's say you go to your Apple calculator here. You would put 20,000, and then you would divide by, let me get mine out real fast. Here it is. I just want to make sure that I'm doing the way they are. So you would put 20,000. Then you would hit the division sign. But this is where you have to be really careful. Make sure that this product is in parentheses. Okay, so 20,000 divided by, open parentheses, 0.04 times 5, close equals. If you forget about this little detail, if you leave out the parentheses, it will think you mean this. 20,000 divided by 0.04, and then the entire expression multiplied by 5, which is not correct. So these have to be in parentheses. So if you did not get the right answer, there's a very good chance that this is the reason. Now, algebraic, you see how here it's not written the same way. This does mean the same thing, but why don't you think about it like this? Or something like that. So that just remind yourself that it's the entire expression that actually needs to be put in parentheses when you're using your calculator. Now, of course, if you have a different calculator, even if you do have a different calculator, you will need these parentheses. The keystrokes might be slightly different, but the logic is exactly the same. The calculator doesn't know what you want. It only knows what you tell it. Okay, so be careful with that. Well, now, if we can take our original formula and rearrange it to solve for the principal, why can't we rearrange it to solve for the rate? Well, the answer is we can. How do you like that? Well, this formula is really amazing, isn't it? So how do I do that, though? I'll divide out both sides here by PT, and that will cancel out. And guess what? Wow. This is an amazing formula. It's crazy how much you can get out of this formula. So you might decide, well, let's figure out what rate of interest we're being charged if we know the interest we're paying, the principal that we borrowed, and the time frame. All right, here's an example. Now, by the way, I just want to, as a side note, you may not have seen this before. When you go to a bank, they'll offer you the opportunity to put your money in a savings account, which means it just sits there and you earn interest, but you can't write checks against it like you can with a checking account. Now, a CD, though, is a different kind of savings account. In this case, the money must stay in this account for the full year. Because you're committing yourself to leaving it there, but it pays more interest. In exchange for that inconvenience, it pays more interest than a savings account. Okay, so that's what this is all about. If you've never seen one before, the next time you go to a bank, a physical bank, yes, they still have them, by the way. An ATM is not a bank. A bank means there's people in there, and they're doing all kinds of interesting things like lending money and borrowing money and all kinds of other fun activities. But look around and look at the signs that they have hanging up there, and you'll see that among many other things, they'll have a list of CDs. The maturities range usually from 1 to 10 years, and they'll all have different rates of interest. And you'll get a chance to see what kind of interest rate we're earning. In fact, let's do some more research on the internet. What rates are currently being paid on 1-year certificates of deposit? Oh, now see, this is what I mean though. 0.75, these are not high rates of interest, but we got 0.007 from our savings account. You can see this is a pretty significant improvement. The only thing is you've got to leave the money there for a year. And also in some cases, you also have a minimum deposit. But if you've got money that you're sure you're not going to need for at least a year, you might as well take advantage of it. Put the money in one of these CDs and you'll get not a lot of interest, but certainly a lot more than you're getting from a savings account. So, and if we looked at, let's say, let me jump that up to 5 years, they should go up even higher. Oh no, boy, they didn't go up very much. Well, this one is 1.01, this is 0.9. That's kind of disappointing. Yeah, they're higher, but not much. No, you have to make up your mind. It depends on the individual. If you're saving for your retirement, maybe you might want to throw your money in one of these because you won't need it for a while. But anyway, so let's just say that in this example, we've got $1 million put into it. Wow. That's our principal. Somebody has $1 million to save. And it's 1 year. And the simple interest is $20,000. So the question is, what rate of interest is he getting? All right, so remember the formula here is R equals I over PT. So why don't you take out your calculator and tell me what you think is the rate of interest here. All right, let's see who can come up with that one. All right, here we go. Okay, ooh, 50. Why don't you go back and double check? Did you use parentheses? Ah, there you go, 0.02. All right, that is exactly correct. 2%, that's right, 2.02 is 2%. And again, don't forget about now here it's a 1, so it shouldn't really matter very much, but oh, I see what happened. Okay, all right. But now you have the right answer. Okay, so yes, that's exactly right. So remember in the calculator, it's 20,000. Oh, by the way, I don't think you're allowed to put commas in there. Let me just see. Every calculator is different. Some of them will allow that and some of them won't. Yeah, it doesn't look like they're putting it in there. Oh, they're doing it for you automatically. Well, that is awfully nice. So it's 20,000 divided by open parentheses. Now here, of course, it doesn't really matter because you're looking at it at a 1 though, but still just in general. This will give you 0.02, which of course is 2%. How do you know? I don't know if there's a percentage key in this calculator. But even if whether there is or isn't, just remember, you're just multiplying it by 100. Okay, so in other words, 0.02 times 100 gives me 2%. All right, well, there's one more factor that we have not calculated, and that's time. So there we go. Once again, this amazing formula can be rearranged algebraically to solve for one of these other variables, the only one we haven't done yet, which is time. Now, this one can be a fraction. And remember, this is measured in years. So if you get, like, let's say 0.5, that means 6 months. Okay? Just be aware of that. All right, let's take a look at our example now. So this time, we're assuming, of course, that you know how much interest has been paid, what the principal borrowed was, and what rate of interest was charged. And then we just want to know how long this loan must be for. Okay, or in this case, we're actually putting money in a CD. All right, let's check this out. An investor puts $100,000 into a CD, and it pays 3%, right? And the interest, simple interest, is I equals 30,000. So remember, the formula is T equals I over PR. So why don't we figure out how long this money must be kept in the CD? It is indeed 10 years. Yes, it is. And how do we know that? Yes, here we go. Okay, so remember on the calculator, put 30,000 divided by, open parentheses, 100,000 times 0.03, close equals, and you will get 10, which means 10 years because it's T. All right, remember, T is measured in years. So whatever number you get is the number of years. And if it's a fraction, Well, that's a different story altogether. Okay, now the next topic that we're about to consider is called compound interest. Now, this is a very, very complex topic. And yeah, this is, I'm not sure if it makes sense to get started with this right now, because it's not that it's time to go just yet, but this is such a complex topic that I'm wondering if maybe, even though it's a little early, if we stop early, you all have to promise to spend that extra time on your midterm. Can we do that? If I put up a poll, yes. Okay, I'm reluctant to start this right now because it's a very complicated idea that requires a lot of background discussion. And I don't want to rush it through this and then have to start all over again next week. So let's just stop here. You deserve a little break anyway. This is a very complicated chapter as it is. And then, use that extra time wisely. And so make sure you have your midterms ready by next Monday night at midnight. And in the meantime, of course, if you're stuck on anything, you can send me emails. And also a reminder, try to send your midterm to my purchase account. And also, if you can remember, try to put your name in the file, the title of the file, try to squeeze your name in there. It just makes it a little easier for me to keep everything organized. And yeah, so when you take your pictures, make sure you take a good look at them and make sure I can read them. I do occasionally get these tiny little pictures where they're all fuzzy and all this and that. Just take a peek at it. If you can't read it, I can't read it. All right. So anyway, in the meantime, I guess we'll stop here a little earlier, but with good reason. And so hopefully you'll be able to take these extra minutes and use them to get your midterm ready. And then I will see you all on Monday. Okay. All right. I'll see you Monday.
Thank you.
All right.
Thank you. Have a nice
Okay,
weekend,
see you later.
Professor.
Thank you.
Okay. Bye.